So we'll work out an example now using the ellipsoid of inertia in order to emphasize just how easy it can be once we have these expressions to get the moments about any particular axis. So for the example, we're going to use our square on the xy plane, because we already know what the inertia tensor is, so we don't have to rederive that. So I'm just going to write down again for completeness what we had worked out for the inertia tensor. 1/3, 0, 0, 0, 2/3, and this I naught, recall, was ma squared. So the square was side length A. So from the expressions for the inertia ellipsoid, all the quantities that we need are in this tensor, so we can immediately write down the inertia ellipsoid. So it's I naught over 3 rho x squared, I naught over 3, so this is Ixx, this is Iyy, rho y squared, and then there's 2/3 Izz rho z squared, and then we have minus two I naught over 4. So we pick up the factor from the product of inertia, and I naught over 4 rho x rho y, and that equals 1. So we have 1 from here and 1 from here. So that's why there's 2. So this is our expression for the ellipsoid. And now we have to define what the axis is. So this row vector is defined by the axis of rotation. Because remember, it's related to the direction cosines divided by the square roots of the moment of inertia. So let's just assume a rotation about the x-axis. So in this particular case, if it's a rotation about just the x-axis, then rho x becomes 1 over root Ix. So this is always the moment about the rotation axis. Cosine alpha becomes 1. And then the other variables, rho y is 0, and rho z is 0. We're not rotating about these axes, so the direction cosines vanish. So this is all we have. And we plug into our expression here. So these terms all disappear. And what we are left with is I naught over 3 Ix equals 1. And so Ix is I naught over 3. Okay, we already knew this. That's just this term. But it's the good sanity check that we know what we're doing. Always a good thing to do is, when in doubt, plug in for a case that you already know the answer to make sure that you really are getting what you believe you should be getting. So I can also do rotations about any axis I choose, but let's rotate about a principal axis. See if we get the number that we think we should. And for this principal axis, I'm just going to choose E1, which is 1 over root 2, 110. So this was the eigenvector that we had derived in our example much earlier. And now row x becomes 1 over 2 I1, and that should be a square root here. And row y becomes 1 over root 2 I1. And now we plug these values into our expressions. So again, this term disappears. This term now survives. And our equation, when I plug these values in, becomes I naught over 3, 1 over 2, I1. So that's our first term. I get exactly the same thing for the second term. I naught over 3, 1 over 2, I1. And then I have this term, which gives me a minus I naught over 2, 1 over 2, I1 equals 1. And when I add this all together, I get I1 is equal to 1/12 I naught. And if you go back and look at that example that we had worked out, this was our first eigenvalue. So again, everything is making perfect sense. We're doing things consistently right. So those are very simple examples. And next we'll do something a little bit more complicated about an arbitrary axis where we don't already know what the answer is.